Hey, my name is Courtney Blunt, and I'm a second grade teacher at Frost School. This is my 14th year of teaching there, and it has truly been a blessing. You're about to view a math video that started off kind of rocky, but ended up being pretty successful. I was very pleased with it and the amount that my students grew throughout the lesson. All right, hope you enjoyed. In this first clip, the students began working independently on their I Ready Try It problem. This followed our 3 reads of the problem, where we discussed what the problem was about, what we were trying to find out, and what information was really important. So as I circulate around the room, I observe the strategies that students are using and pay close attention to how they're forming their equations. This helps me quickly assess their level of understanding and determine whether their equations accurately match the information in the word problem. It really just helps me understand if they really know what this whole entire problem's asking. Be very careful when you're doing your math, guys. Make sure you're adding or subtracting correctly. I see little simple mistakes. Make sure you keep your eyes on your own paper during this time, okay? It's just independent work. Unless you're drawing math models, okay? Okay, so as I circulated, I began noticing the same errors appearing in several students' equations. Time after time, I would go to each group and I'd be like, oh, seeing the same thing. So it showed me that many of them just weren't really connecting the information from the problem to what their equation represented. They just couldn't make that connection. So instead of continuing in partners, I just said, okay, let's stop, let's pause, let's meet back together, and let's make sense of the problem again one more time as a group. So we started back over asking all of the same questions. What's the problem about? Who's it about? What information is important? What are we trying to find out? So at this point, my goal was just to help the students visualize the problem. We call it a story, what's happening in the story. So we just took our time and looked at it sentence by sentence by sentence and discussed each part thoroughly. After that, I had the students revisit their equations that they had previously written, and they had to check to see if their equation accurately showed the information from the problem. This helped them move away from simply solving for an answer and more toward understanding the structure and the meaning of the problem. Class?
Yes, yes.
I need your ears and eyes.
And eyes.
All right, I want you to look down at your work really quick. Look at the equation that you wrote for Miss Courtney in your try it problem. Now, I want you to think about these things. What is this problem about? Okay, we're switching it up a little bit. I'm hoping that you've already thought about these. Okay, what is this problem about? What? Ticket. Very good. What are we trying to find out? Raylan?
You're trying to find out the answer.
Okay, I don't need to know the answer yet, but what are we trying to find out exactly? Of course, the answer. But Bowen, what would you like to add to that?
Like to add to Raylan, we're trying to find out the answer to how many tickets they had on first week.
That they sold during the first week?
Yeah.
Okay. All right, very good. So what information is important? And the reason I wanted you to look down at your equation is because I wanted you to think about this. Did you use this information to solve your problem? Did you use this information in your equation? What information is important? A class has 500 tickets to sell for the fun fair. Is that information important?
Yes.
It is? It isn't. I need somebody to tell me. I have some people going, yeah.
Yes.
Okay. Becca, you said no. Why is 500 tickets to sell at the fun fair not important? It is important. I agree. It is important. It says that they have 500 tickets to sell. Okay? If you look at the second sentence, it says some tickets are sold during the first week. Now, if I have something and I sell some of them, am I going to have more or less? I'm going to have less. So does that let us know that we'll probably have more than 500, less than 500, what? Less. So if we're going to have less, we're going to do this or this?
This.
Okay. All right. How many of you did that in your equation? How many of you set up your equation that way? Okay. Now, the next one, it says, after the first week, the class has 278 tickets left. Is that important? Yes or no?
Yes.
Okay. What is that really saying? If I was to set it up as a start, change, result, or start, or, a start, change, result problem, what would 278 be? How many I started with? What changed or the result? Okay, what changed? Okay, so you're telling me that a class has 500 tickets and they sold 278 tickets?
No.
That's what changed?
That's
The result. Good, good. I'm just asking all this. I just want you to start thinking about it. So, how many did they start with then?
500.
What changed? They did what?
They
sold some. So is the information in the second sentence? So everybody look at the second sentence. Is that information important? Yes. I mean, oh, good. Okay, so you told me that the first sentence is important. The second sentence, we know the third sentence is important. Now, we already underlined our question. How many tickets does the class sell during the first week? Is it all important? Did we have to use every single bit of that to write our equation?
Yes.
To solve our problem? Good. So after the students had time to revise their equations and really look at them again, they met back with their partner to share their strategies. During this time, they use their little math movements. They discuss, they say whether they agree, they disagree, or what they would like to add on. They compare their equations. They explain how they solve. They do all of this very respectfully. They really build on one another's ideas. So through the years, and especially this year, I found that this part of the lesson is actually probably the most powerful, just because students often learn best from each other. Sometimes they can explain something to their peer that just clicks faster than any explanation that I can give. Actually, they've taught me a few things this year too. So this time allows them to take real ownership of their learning and use math language naturally as they justify their thinking and as they support each other. Now I want you to share your answer and discuss how you got it with your shoulder partner. I don't want to know your answer yet. Okay? So you're going to turn and talk with your shoulder partner. Teach.
Okay.
Oh, class.
Oh, yes.
Teach.
Okay.
Thank you. Yes, Harmony. Yeah, please. All right. I want to know what y'all got, how you got it, all of that good stuff. Did you add? Did you subtract? What did you do?
I subtract.
Okay, what did you subtract?
I subtracted
221. Okay. I don't hear a conversation over here, and y'all two both like to talk.
And second one
You got 378? What's that? What y'all get, man? What y'all get? Okay. What strategy did y'all use? Standard algorithm. Both of y'all did? What did y'all use?
I use standard algorithm.
Okay. Ooh, I love your sorting problem. I love it. You use beginning, middle, end. Start, change, result. Good. You can have it in math. Rebecca, what's the drawing for?
You said to do it again, but what did
What was your final answer?
500 plus 10.
So, question, if you was to take 278 and add 132, would it equal 500?
Check.
You should check. If that's our family members, that should be the case. In this next clip, one student shares a strategy with the class, and you'll hear me connect it back to fact families. We use fact families a lot in our class just because I really want students to understand how addition and subtraction are related and that there's rarely just one way to solve a problem. When students understand those relationships, they can choose the method that makes the most sense to them. It kind of takes the math scaries away. They can, solve the problems the way that they feel the most comfortable. Some prefer to add, some rather subtract, and that's okay. But what matters is that they understand how the numbers work together and that they can use that connection to solve accurately and with confidence. So who would like to tell me their final answer or share with the whole class their final answer? Weston, you have the floor. Everybody, Weston has the floor.
What I would like to share with the class is I got 132.
132. Okay. How did you get that answer, Weston?
I subtracted 500 minus 878.
Okay. Why did you decide to subtract 278 from 500?
Because if you use 278 and add 132, it equals 500.
Okay. So you said 500 minus 278 equals question mark. Is that how you set up your first equation? Okay. So does that mean that you're saying that they started with 500 and then they sold 278?
No.
It doesn't mean that.
What it equals is how much they sell.
Very good. What it equals is the answer to our question, right? And the only thing that we have to make sure in a subtraction problem is that Big Papa starts it, right? We can switch the other two numbers. Okay? So, where's my stuff? Let's see my little pen. Ugh. I'm always losing stuff. Y'all see it? Right here. Okay, so Weston, can you tell me how you set up this problem? You want to come do it? Right here? Everybody looking and listening. What does that represent? Start, change, or result?
Start.
Okay. Aren't you thinking about if you agree with this or not, guys? What does that question mark represent?
The result.
That represents the result? Okay, that represents your answer, but good job. Everybody give him a round of applause real quick. All right, and ears and eyes.
Ears and eyes.
All right, so Weston, set this up good. He's good to go. We started with this. We subtracted, or we sold this. And then we end up with that. So really, this would be our start. We sold how many?
210.
No. Really?
Some.
Here's our change, right? What change? We sold some. We don't know how many. That's what we're trying to figure out. And our result is 278. But like Weston just explained, we can switch these two, right? Can we switch that in the subtraction problem? No way, Jose. So we could say that's because of fact families, right? Okay, that's why Beckett and Kylie, I said you needed to take your answer and add it to this to see if it equaled that, right?
That's what I did.
Okay, all right. So good job. Now let's look. Let's see. How many of you use standard algorithm? Most everybody did when I was walking. In this clip, students are applying the same process to a second word problem from their iReady workbook. This time, they're not working in with their shoulder partner. They're working in their level table groups. They are talking through the problem and trying to write an equation that matches the story before they solve it and show their work. I love this part just because they really guide each other through the process, and you can see their reasoning grow as they use equations and models to explain what's happening in the problem. You could just really see a whole lot of growth during this time. And they do it so respectfully, and it's just amazing to watch. Okay, number 6, y'all read it. Always read them 3 times. Oh, good. All right, come on. Let's do it. Let's do it together. Hey, sir, sit. Get to work. Oh, we need to be starting already. We don't need that. That's early finisher. Right here. Come on, y'all should be reading already. You have to read it 3 times before you start. Let's go. Let's go.
Sitting 400. How many seats are empty? Use 2 different strategies to solve this problem. Show you what.
Okay. How many strategies do you have to use?
2. I'm gonna like subtracting and plus.
You think so? Either one. I don't care. So you could use standard algorithm if you want to, then draw it out. You could use one of those super strategies you learned today. I don't care, but you have to do this together. All right.
Start.
Yeah,
No.
if you wanna do the story map, start, change result, or beginning, middle, end, whatever. Okay, let's look at it like that. Everybody listen. There are 700 seats. There are people sitting in 463 seats. The rest of the seats are empty. How many seats are empty? Okay, so let's just pretend for a second. This is a story, okay? There's 700 seats, empty seats available. Okay? How many?
700.
Are we gonna like build more seats or add more seats or anything like that? No, that's
the total amount.
So we're starting with that?
Yes.
Okay. Something's gonna change though. People walk in and sit in 463 of those seats. Do I add to 700?
No, you cannot. You have to minus this.
Okay, so out of those 700 seats, 463 people sit in them? Or,
Yes.
Okay. So the rest of the seats are empty. How many's
But
empty?
you don't know.
Okay, so how would you set this up?
You would say 700 minus 463 equals question mark.
So our start is 700. What's our change?
Our change minus
463. So you're saying 463 people come in and sit.
then question mark.
And so the result is the question mark. Okay, what can you do to solve it? So after we reviewed the group work together, and I went over the solution, talked about it with everybody, answered all of the questions, I gave the students one final problem to try on their own. They would be working completely independently with no help from their partners this time. So it really just served as a quick check for understanding, so I could see who is ready to move on or who might need a little extra support here in small group. It really helps me plan for what comes next. Hands on top. Thank you. All right, there are 700 seats. There are people sitting in 463 seats. The rest of the seats are empty. How many seats are empty? What are we trying to figure out?
How many seats are empty?
Is it going to be 700? Is
It's
it the 463? No. Do we have to use those numbers to figure out?
Yes.
Okay, so all of the information is important, right? What are we talking about? Seats. How many did we start with?
700.
All right. What changed? How many sat?
463.
And then we're left with an unknown number, right? That's what with the rest, okay? All right, with the result, okay?
No.
So how many of you got a 2-digit number as the answer? Nobody, good. Did anybody get a 1-digit number as the answer? How many of you got the answer and your answer has 200s in it? Your answer. How many of you got the answer and your answer has 200s and 3 tens in it? And how many of your answers have a 7 for the 1s? So what is that answer?
237.
All right, very good. We have like 2 minutes left, guys. I need you to do number 7 on your own. Obviously, the lesson was not without flaw. It started out pretty rocky, but it ended up being a very productive lesson where I was super proud of my students. Throughout the lesson, I saw them shift from uncertainty to confidence, and their understanding just really grew. They began with some confusion, but through discussion with me and with their peers, they would revise their thinking and reflect together. They pushed their understanding deeper. And then just for me, being able to listen closely and check in on their thinking, I was able to quickly adjust my instruction or my lesson and the instruction in the moment, and not just prolong it, you know. And I think that's important to see that, I mean, because that does happen often, you know. You got to just kind of stop and go back, not just keep on going just because you're trying to reach a deadline. You know, you have to adjust and meet your kids where they're at. But then, you know, after more discussion and more working through it, you know, they were able to, you know, write accurate equations and use strategies to solve the problem. I just love seeing those light bulb moments and when the math finally makes sense. And I'm proud of how they supported one another and truly made sense of the problem. I'm just really proud of the students.